Because I remember when I said checked answers, then it shows 0 the whole time.
Yeah, it's because I don't know why it's doing that. By default, I think it's just marking wrong answers. I'm not sure why. But after I've marked them, it's only about 4 of you who did it. So I marked it, then I sent it back. Just check your email because I sent the answers.
Okay.
Yeah, just double check on it. So we're going to be sending more of those so that we see what you guys are doing, because sometimes it's easy to mark like that. I'm just going to find something that will straight away give you the right answer. But so far, I'm not sure what's wrong with this system here. Because it's supposed to give you the right answer straight away. So I'm not sure why.
Okay.
Yeah. But no one got, from what I've marked, no one got a 0. I think the lowest was, I think a 4 or something like that, or a 2, I'm not sure. Right. So we're gonna start. We're gonna start. We start with exercise 15. All right. I take it everyone has done this. Because for now, with electricity, we are done. So what we're just doing is to practice. So with term 2's work, we are done. So it's a matter of just practicing some past papers, and we'll move on to term 3's work. I think some of the topics from term 2 might be taken out. There's a new work schedule or amount of work that you need to know. Remember, they reduced it from 100% to 80% because of the term that we've lost without going to school. All right, but some of the topics, unfortunately, they feature in your matric. So they, even though they fall in term 2, which is going to be trimmed, you're still going to be tested this in grade 12. So you still have to know this. All right. So we'll go over everything so that you guys, you are not disadvantaged anyhow. But anything that we are doing you don't understand, please ask as well. All right, so we start. The first question there, it was exercise 15. All right, we've got exercise 15. It says here, potential difference calculation worksheet. So you've got potential difference is equal to work done divided by charge. We did look at that particular equation there. V is equal to W over Q. All right. So here, in the first question, you are given find out the unknown quantity. So here you've got your voltage is unknown. Your work done is 45, and your Q is 15. All right. So what are you going to do? You're looking for V, so you go to your equation. Your equation is V is equal to W over Q. V is equal to W over Q. Let me just see if I can put this on the whiteboard, then I can write it. Just a second as I move to the other slide. Okay. Right, so we have, just open this. Okay. And I'm just going to take this. Just a second. I'm just opening this. Just a second. Okay, so this is what we have here. You are given there 45, you are given volume is unknown, is not unknown, sorry, is unknown there, right? Then your volume is 45 joules, then your charge is 15. So you're gonna use your equation. The equation is given here for you. V is equal to W over Q. So you're gonna write your V is equal to W over Q, right? Then your voltage is unknown. So you're gonna substitute, then you're gonna get your 45, right? 45, which is your work done, divided by your 15 coulombs, which is your charge. Then your answer is gonna be equal to 3 volts. So that's how you do number one, A. That's your A there. All right. Then you go to B. B, you are given V, 9 volts, work done is not known. Then your Q is 150. So from your formula there, I've just put this one here for you to see. So your V is equal to W times Q. So for you to get, we are looking for work done, sorry. Work done is equal to, remember this means divide, this one here means times. So your W is equal to V times Q. So your work done is equal to the voltage multiplied by the charge, right? Which is going to be equal to your voltage there. You're given 9
times 150.
Times 150, yes. 9 times 150. All right. Then you get your answer there. 9 times 0 is going to be 0 times 5. That's 45. Remember 4. 9 times 1, you're going to get 1,350. And your units there must be joules. Right, so that's what you get for number for B. So this becomes your B here. Right, then you go to C. C, you are given V 1,5 volts, work done 225. You are looking for Q. So going back to your equation again, Q is equal to W divided by V. So basically here, I'm just using this, but in an exam, you're only given one equation. So basically what you do, you substitute, then make the subject. Don't start by making the subject, because if your formula is wrong, then you're gonna lose everything. So just substitute into the equation, then you can make your subject, so that you don't forfeit marks for the formula and substitution. So for C, what I'm trying to say is this: you're still gonna write your formula V is equal to W over Q. All right, then you substitute. When you substitute, your V is 1,5 is equal to your work done. Work done is 225. Get your 225 there. Divide by
Q.
Right. Divide by Q. We are looking for Q, so you get your Q. Right. Then you have to make Q the subject of the formula. You know this is 1/1. So these two are gonna swap. Q is gonna go there.
Cross.
And yes, you cross multiply basically. So you're gonna, then the 1 is gonna multiply with that other one there. So you're gonna cross multiply. Then therefore your final answer, your final form here is gonna be Q is equal to, right? So Q is gonna go there. 1,5 is gonna come here. So your answer is gonna be 225 divide by 15. All right, divide that by 15. You punch that in your calculator.
So is it,
yes.
Isn't it 1.5, sir?
Oh, sorry,
isn't it
1.5? 1.5, yes, correct. Not the yes, so it's 1,5. So you're gonna divide 225 divided by 1,5. Then you get your answer then. Clear? So this is kind of straightforward. It's not very difficult. So just for you to familiarize yourself with the formula, V is equal to W over Q, where V is your potential difference, W work done, Q is your charge. Clear? Right, then we move on to the next one. Draw a circuit with a cell and a bulb in it. Show on the diagram conventional current and electron flow. So basically what they need on this question is for you to draw a circuit. So you have a cell, so you're gonna have a cell, just one cell, that's a cell there. All right, if I'm gonna put another one here, then it becomes a battery. So a cell is just one,
Okay.
all right? Then, and a bulb, so I'm gonna have a bulb, all right? So that's my bulb there. Shown the diagram, the conventional flow of current. So I can just put my wires there. All right, then I've got my other side there. Then I've got my, maybe my switch, but they never asked about a switch, so I can just put a switch, it's closed. All right, then they say show on the diagram the conventional flow of current and electron flow. Right, so we start with the conventional flow of current. Conventional flow of current, basically when they started to discover this, right, they found that they thought that protons are the ones that positive charges are the ones that flow. So they initially they said charges they flow from positive to negative, positive to negative, right? Why? Because they thought it is the positive charges that flow. But later on, they discovered no, it's not positive particles are protons. They stay in the nucleus. They are not the ones that move. It's the electrons that move. So now they become again another, that became the other way, the direction in which current flows. But now when you look at a solution where you've got positive and negative ions, yes, we have got positive ions and negative ions flowing in opposite directions. So they didn't change that. So they called the original direction the conventional flow of current, which is the direction in which positive charges move. So positive charges, they move from positive to negative. So the long line here, that's my positive, right? And the shorter one is my negative. So conventional current flow, it flows from positive to negative. So it's gonna flow in that particular direction. That's the conventional direction of flow of current, all right? So it flows from positive to negative, right? Then we have got now the electron flow. We know electrons are negatively charged. Electrons have a negative charge. So electrons move in the opposite direction. Electrons move from negative to positive. So this is the flow, the direction in which electrons flow. They flow in that particular direction. So that's the direction in which electrons flow. So basically, I think on your diagram, I'm not sure how you label it. Like mine, the yellow one is for electrons, and the green one is going to be for my protons. That's the conventional direction in which current flows. So that's what I'm going to have there. I'm not sure how you labeled it, but maybe you did an arrow to point it out or something like that. As long as it makes sense, then it's correct. Clear?
Yes.
Yes. So please don't forget there's conventional current flow, then there's electron flow. So electrons, they flow from negative to positive. In your mind, you must just know electrons are negatively charged. And we know like charges, they repel. So negative and negative, negative cannot go towards negative because they repel. So negative must go to the opposite side, which is positive, all right? And we have got our
Yes.
protons. Protons are positively charged. So protons cannot flow towards positive. They must flow towards the opposite charge. So protons are going to flow from positive to negative. But the flow of protons or positive charges, that's the conventional one. And electron flow becomes now the opposite, from negative to positive, because like charges, they repel, and unlike charges, they attract. So electrons are negatively charged, so they are attracted towards the positive side. So they flow from negative to positive. Just in case that those two confuse you, you must play around with the charges. Charges, unlike charges, they attract, and like charges, they repel. That's how you you do that one. Clear?
Yeah.
Right. Okay, we move on to the next one. So this was the first part. Let me do another screenshot and bring it here. Okay. Just a second. Right, so there we have it. We have another one here. Okay. All right, can you see this page here?
Yes.
The question, okay. All right, so we start. So number 3 says the potential difference between two terminals on a battery is 9 volts. How much work or energy is required to transfer 10 coulombs of charge across the terminal? So basically, what are we given here? We are given the voltage, we are given V, right? And what else are we given? We are given coulombs. Coulombs is charge. So we're going to use our formula V is equal to W over Q. Over Q, right? Then what are we looking for? How much work or energy is required? So we're going to substitute the V becomes the 9. All right, how much work is done? So we're looking for energy, which is W. You can also use E, it's still fine, over your Q. Your Q is a amount of charge, so it's going to be 10. Right, therefore your W is going to be, you cross multiply, this is over 1, so it's going to be 90. So your answer is 90 joules. So you're going to get your 90 joules there. Right, so you simply cross multiply. Next one, it says 10 joules of work are required to transfer 2 coulombs. So 10 joules, you're given work or energy, are required to transfer 10 coulombs of charge. Right, what is the difference in potential between these 2 points? So you're looking for V, so you simply divide. So for number 4, you're simply going to divide. All right, you're going to have your V is equal to W divided by Q, right, which is going to be equal to, you've got your work done is 10, divided by the quantity of charge, which is 2, your answer becomes 5. So your answer is 5 volts. So you're going to get 5 volts. That's what you have. Then number 5, it requires 600 joules of energy to transfer a quantity of charge between point C and D of a circuit, which have a potential difference of 40 volts. So you have got energy and you've got voltage. So you're going to do your sum there. So you're going to say, what are we looking for? We're still going to start with our equation. So we're going to say V is equal to W over Q. All right, then you substitute. All right, so your V, what are we looking for? Charge. So we're looking for Q. So 30 volts. So we've got 30 is equal to your work done. Your work done is 600 joules. Go to 600 joules, divide by your Q. All right, so you're going to make your Q the subject of the formula. All right, then you're going to have 600 divided by 30. All right, so 600 divided by 30. All right, you cancel that. So 60 divided by 3 gives you 20. So the answer becomes 20 coulombs. All right, so that's what you have for for number 5. So this becomes your number 5 here. That's your number 5. Okay, then we move on to the next one. Find the unknown quantity, convert first to volts, joules, or coulombs. So here you just playing around with your units. All right, so here I'm just only going to look at the conversion. Then the rest you guys can I think this was a kind of straightforward. So here you are given millivolts, 1000 millivolts. All right, how do you convert millivolts to volts? What do you do?
Divided by 1,000.
Times by, what's this, 10 to the power of 6.
All right, milli. Milli is how much? When you say milli, what does that mean?
Million.
Milli. Milli is not 1,000. Milli is 1,000, but it's 1,000 yet. It's 10 to the power negative 3. So remember what you have. Let me just explain to you here. Okay, you've got your number here. You've got your 1. There are numbers that are greater than 1. There are numbers that are greater than 1, and there are numbers that are less than 1. All right. These numbers are between 1 and 0, somewhere there. So if you've got 1, if you go up, it becomes kilo. So kilo is 10 to the power 3. You've got your 10 to the power 3. After kilo, you've got mega. You've got your mega, which I'm using a mouse to write here, so it's not easy. Okay, you've got mega. Like your megabytes. So this is going to be 10 to the power 6. After mega, you've got your giga. Giga is going to be 10 to the power 9. You're going to have your 10 to the power 9, which is like a billion. Then after giga, you've got your tera, 10 to the power 12, and like that and like that. You've got your iota and so on and so on. Then going downwards, you've got your milli. So your milli is sub 1, or it's under 1. So milli means 1,000th, which is 10 to the power negative 3. So it's 1,000th. So when you say millimeter, it means we have taken a meter and we have divided into 1,000 pieces. That small piece that you get after dividing a meter ruler with into 1,000 pieces, that becomes a milli. So it's 1,000th of a meter. If you say millimeter, means 1,000 of your of a meter. We are dividing a meter into 1,000 pieces. That small piece, that's what you call a milli. Right. Then after that, you've got your micro. You've got your micro. Right. Micro is your 10 to the power negative 6, which is a millionth. So it's 1 over a million. After micro, you've got your nano. Nano means 10 to the power negative 9. It's a billionth. So it's 1 divided by a billion. That's the size of a nano. After nano, you've got your pico. Pico is going to be 10 to the power negative 10 to the power negative 12. 10 to the power negative 12. So it's after a billion, you've got the next number. So it's going to be 1 divided by that 10 to the power 12. That's what you get. So these are the units that we're using here. So in that particular question there, in this question here, what do we have? We have got milli. So it means it's 1,000. How do you convert it to volts? What are you going to do?
Times by 10 to the power of negative 3.
Right. Times, yes. So you're basically going to divide this by 1,000 again. So it's going to be roughly it's 1 volt. Clear? So this is going to be 1 volt. Am I right? Right. So for you to convert from millivolts to volts, you multiply by 10 to the power negative 3. So that's what you had. So you're going to have 1 volt here. So your volt is 1 volt. Your W is unknown. then your Q becomes your 20 coulombs. So using your equation, V is equal to W over Q, right? You're going to have 1 volt is equal to W is unknown, and you've got 20 coulombs. So you cross multiply. So it's going to be 1 times 20, which gives you 20. Your work done will be 20 joules here. Right, we move on to the next one. Next one, you are given here, you're looking for V, and you are given W in kilojoules. Kilo means 1,000, like we saw there. Kilo means 1,000. Where's that page there? Right, kilo is it's 1,000. 10 to the power 3 is 1,000. So you have to play around with that one. Right, so you check kilo, we want it in joules, so we're going to multiply this by 1,000. So it's going to be 1,250 kilojoules. So here you're going to get, when you multiply 1,25 kilojoules times 1,000, you're going to get 1,250. 1,250 joules. So you're going to do your calculations using 1,250 joules to get your V. So V is equal to W over Q. So you're going to take your W, which is 1,250, divide by the charge, which is 15,500 coulombs, then you get your answer. Then we go to the next one. C, V is equal to 1,21 gigavolts. Gigavolts. Giga, what do we say is giga?
9.
Right, giga is 10 to the power 9, it's a billion. Right, it's a billion. So it must have 9 zeros. So it's a billion. So you're going to go back here. All right, so what you're going to say? You're going to say 1,21 multiplied by 10 to the power 9. So your answer here becomes 1,21 times 10 to the power 9. That's your, in volts, that's what you have, 10 to the power 9. That's what you're going to have. So in your calculation, that's what you're going to use for you to get the work done. Then you're going to divide it by 2 million of charge. Then that will give you the answer. Is that clear? Right. So this activity here was just testing you on how to convert these millivolts, kilojoules, gigavolts, just to know the conversions there. Right. Any questions so far?
No.
Okay. Right. If there are no questions, we continue. So this is the part that you had for potential difference. Then we move on to current. Current also easy, right? What are you given here? I'll just do a few of those, then we proceed if we still have time. All right, let me just take a screenshot of this. All right. Okay. 10 minutes left. Okay. Where is it? Yeah. All right, so this date is, I hope you can see it. Okay. All right, I'm just going to delete this. All right, so I need a new page here. All right, so your current, you're given there. Current is given by Q over T. So current is the rate at which charge flows. So in this particular question here, you're given I is 0.4 amperes, Q is unknown, time is 20 seconds. So what are we looking for? We're looking for Q. So the formula for Q, I didn't take this screenshot nicely. So basically, your triangle there is supposed to be something like this. It's your Q here, and that's your I, and that's your T. So your quantity of charge is equal to current multiplied by time. So time is going to be quantity of charge, or charge divided by current, and current is charge divided by time. So here we are given current is 0.4 amperes, quantity of charge, it's unknown, then time is 20 seconds. So we're looking for Q. So my Q is going to be equal to I times T. So it's going to be I there, all right, multiplied by T. Then I'm going to get I'm going to get my quantity of charge, my current is 0.4 multiplied by 20 seconds. then I'm going to multiply the 2, then I get my answer there. All right, so I'm going to get my answer, which is roughly how much? It's going to be 10, 20, it's going to be 8. Am I right? It's 8,
Yes.
no?
Yes.
Right, 8 coulombs. Please make sure the units are correct. It's supposed to be 8 coulombs there. Right, then we move on to the next one. The next one, we are looking for current. We're given charge and time. So we know from the equation, you can start with the same equation all the time so that you don't make mistake when you do the subject. So you're gonna have your, what are we looking for? We're looking for I, all right? So if I simply use Q again, Q is equal to I times T, so that I get the mark for the formula, all right? This one, because I'm making the subject, I'm gonna write it at the bottom here. My Q is gonna be 240, all right, is equal to I, my I is unknown, so I've got my I, current, multiplied by the time. So my time is gonna be 300 seconds. I've got my 300 seconds. Then I've got my my I, my current is gonna be 240 divided by 300. Then you play around with your calculator. Then you get your answer. All right. So you're gonna play around with your calculator. Then you get your answer. Then the last one. What do I have? I'm given current 2 amperes. Quantity of charge. Quantity of charge is 400. Then I'm looking for the time. So basically, your time is going to be Q over I. What is my Q? My Q is 400. And what is my current? My current is 2. So it's 400 divided by 2. My answer is 200 seconds. Then we look at the next one, converting units to seconds. So what are you given here? Find the unknown quantity. What are you given? You're given, you're looking for I. I is unknown here. All right, quantity of charge 140. Your time is 4 minutes. So you have to convert minutes to seconds. So you're going to multiply 4 minutes, multiply by 60. You have to multiply this one by 60 because a minute is 60 seconds. So you multiply by 60, 60 by 4, you get your 240 seconds. So in this equation, you're supposed to use 240 seconds. All right, then you substitute into your formula. I is equal to Q over T, then you do your sum, then get the answer. So here, just testing you in terms of conversion. So here you're gonna have your Q is 140 divided by 240, then you get your answer. Then we come to the next one here. You are looking for Q. Q is unknown, so that's what you're looking for. Your time is 1.5 hours. 1.5 hours in seconds. So you're gonna have to change hours. You change hours to minutes, all right? Then you change minutes to seconds. And in between, you are multiplying by 60. So it's gonna be 1,5 multiplied by 60. And then the answer that you get, multiply again by 60 to get seconds. Clear?
Yes.
Right, then we go to C. C, what do you have? We've got current is 0.9 amperes. All right, you're also looking for Q here. All right, quantity of charge, your time is in minutes. That's easy. So you're gonna multiply this one by 60 to get seconds. So you're gonna get 180 seconds. Then you use that 180 seconds to calculate your Q. So basically, these two are almost the same. The formula that you're gonna use after making the subject, the difference is that here you have to convert hours to seconds. But this one is similar to the first one where you have to convert minutes to seconds, then you get your answer. Right, moving on, we've got about 4 minutes left. Okay, let me just check another slide that I have here. Okay. Okay, let's see on this question here. This question, then there are some word problems. These are almost the same. You're gonna do the same like what I've done here. Let me just screenshot this. Okay. There it is. Can you see that?
Yes.
Right. All right, so here, this is what you have. I'll just quickly go over this. You are given here the current of 10 amperes in a second of, if there's a current of 10 amperes in a second for 10 minutes, so you've got 10 minutes. What quantity of charge flows through the circuit? So first you have to convert these minutes to seconds. So you're gonna multiply by 10, by 60. Then you're gonna have 600 seconds. Then using your formula Q is equal to IT, then you play around with that to get your Q. So here you're gonna have 10 amperes multiplied by 600 seconds, then you get 6,000 coulombs. Then you go to the next one. How much current must there be if the circuit in a second if 100? So you're given charge coulombs, 100 coulombs, flow past a point in a second in 4 seconds. So here you're looking for current. So you're gonna make I the subject of the formula. So you're gonna have your charge, which is 400. 400 divide by 4 seconds. Then your answer is gonna be 100, right? So it's gonna be 100 amperes. That would be the answer for number 2. That would be for number 2, yeah. Right, then the last one. The last one says, how much time is required for 10 coulombs of charge to pass or to flow past a point if the rate of flow is 2 amperes? So here you're looking for time. So your time is equal to Q over I. Q over I, all right, which is going to be equal to your Q. How much time? You've got 10 coulombs as your charge, divide by your current, which is 2 amperes. All right, your time is going to be 5 seconds. So this is how you guys are supposed to do that particular activity there, right? That's all on these 2 activities that we had. Then I think because our time is up, we'll continue in the next lesson. Yes.
So I wanted to ask, how is it 100 amperes for question 2?
For question number 2, this one.
2. Yeah.
This one.
Yeah,
Please,
that one.
some mistakenly divided by what is made 100 columns for 100 columns.
Oh, okay. I think this could be a mistake. The answer cannot be 100. I think just check it out again.
So
Our time is almost
25.
up. Yeah. Yeah.
Okay.
Yeah. Just double
I got
check it.
25.
Right, guys. On Friday, our lesson we're not gonna have it at 2. We're gonna have it at around about 2:30 because I'm going to school. There's some training, and Friday it means that it's gonna disturb my grade 11 at 1. So you guys, let's have it at 2:30 on Friday. Is that clear?
Yes.
Okay, our time is up. Enjoy your day. Let's meet on Friday. I'll post some questions again for you to do like the one that I gave you today.
Okay.
All right, thank you. Enjoy your day.